Okay, so I have not marked your quizzes yet, but they're on top of my list to do. But one of the elements of the quiz I thought that we haven't really spent enough time, or any time on, I say enough, I mean any time, is actually doing expansion work. I kind of forgot there were a couple of, we've got plenty of time to correct my mistake, but I kind of forgot there are a couple of particular cases where you wouldn't have covered in 9 Maths Core, and so I want to go through it now. And I just thought we'd start with a slightly trickier expansion that you can see up on the screen now. So we've got a binomial x minus 2 multiplied by a trinomial x squared minus x plus 3. So it's a binomial multiplied by a trinomial. And I'm going to show you 2 ways. One is just the box method, which you would have seen before. And I just thought you've probably utilized the chicken beak method before, right? Yeah, of course you have. But I thought I might just show you how it looks for a 2 by 3. So here we go. No, I don't need the popping noises. It's like you know what? I'm not going to name check you because I think that's what you're looking for. So stop it. Don't even try. So we've got x minus 2 times x squared minus x plus 3. Now, it's the standard procedure that we've already used in a 2 by 2 expansion. And that is basically everything has to be multiplied by everything else. Now, in the box method, what we do is we draw our box as usual, but instead of having a 2 by 2 box, we have a 2 by 3 box, right? But apart from that, it's pretty much the same. So I put my 2 parts to my binomial down the side, and I put my 3 parts along the edges there, and then I fill out the boxes. So x times x squared is x cubed, x times negative x is negative x squared, and we've got plus 3x, and then we've got minus 2x squared, positive 2x, and minus 6. I put the signs in, even if it's positive, because what I'm going to be doing next is I'm going to be adding up across the diagonals, right? That's how the box method works. You're adding along the diagonals. If there's more than one set of diagonals, keep going. Left to right diagonals. You right, Chris? Okay, so that means we've got x cubed, and we've got minus 2x squared minus x squared is minus 3x squared. We've got 5x, and we've got minus 6. So these 2 bookend it, start and end, and then across the diagonals for the 2 middle terms. Done. Really good to see 4 people writing these notes down. Everyone else, very well done on not needing to. Just for the recording, I'll just note that moment of silence was while they're getting their books out, and while I give a certain student the hard stare. So that's the box method. Lovely. Works pretty well. Bit not clunky, bit bulky to use, but it works. And if you're a visual learner, if you're someone who likes to have sort of it all pictured out, I think it's pretty good. I'll give you the chicken beak method for an alternative. What do I like about the chicken beak method? I like it because it's a bit more compact. I like it because it's what I grew up with. But honestly, use either of these methods that you want to. I think when you're getting to a binomial times by a trinomial, doing it all in your head's getting a bit too much though, I reckon. So you should have some sort of method. Now, genuinely, has anyone heard of the chicken beak method before? Yeah. I have. Have I talked about it? Yeah, cool. Okay. So it's just an extra stripe to your chicken beak. So you got x minus 2 multiplied by x squared minus x. I have to write it again so I can put my little chicken beaks in. So we're going to go x times x squared, x times minus x, x times 3, and then we're going to have 2 times x squared, minus 2 times x squared, sorry, minus 2 times minus x, and minus 2 times 3. So we've got this lovely looking stripy chicken beak. Okay, so what I wanted to point out, I didn't think we'd done any expansions at all, so sorry if I'm repeating myself. What I wanted to point out is my setup. So I multiply x by x squared and get x cubed, and then I multiply x by negative x and get minus x squared, and I multiply x by 3 and get 3x. So that's basically, I'll just put a little blue dot there. That's where it's come from. Then I'm going to multiply the next things out, and I've got minus 2 times x squared, and it's equal to minus 2x squared. But what I'm going to do is I'm going to put the minus 2x squared underneath the other x squared term. And that's the trick, I think, to a little bit of setting out really helps clarify what you're doing, rather than doing it as one long line. Then I've got minus 2 times minus x is positive 2x. And then I've got minus 2 times positive 3. So you've got plus 6. So can you see how like the x cubed and the 6 are again bookending it? They're sort of, there's nothing underneath them either side. And then you've got the terms in the middle. And then we just add the columns up then. So we've got x cubed. I'll just dot these so you can see where they've come from. So we've got x cubed minus x minus 2x squared is minus 3x squared. 3x plus 2x is 5x. And because they're underneath each other, it's just so easy to read. Thank goodness I got the same as the box method. Otherwise, I would have made a mistake. But if you can imagine practicing those, that sort of layout with the chicken beak method, if you like that better than the box method, when it comes to a test, if you're just naturally writing them in column order like I've just done there, can you see like under a pressure situation, you're going to make fewer mistakes because the columns are already there for you. And so you can just add them through. What do you reckon? Oh, gee. Okay. Is that yours? Thanks for the extra information. So, just a little bit of, oh yeah, Raf. Because I made a mistake. Thanks, Raf. Everyone else was happy with that mistake, but you weren't. That's better. Now it's the same as the top right as well. I said 2 times 3 is 6, where it's minus 2 times positive 3 is negative 6. Thank you. I very rarely, I always say, but I very rarely deliberately make mistakes on this board, but I quite frequently just stuff things up. So you do need to check on me, make sure I'm doing the right thing.
Why would you make a mistake on purpose?
Some teachers, well, number one, some teachers actually do make mistakes, but for some reason they're too fragile to admit it. So they say, oh, I did that on purpose to see if anyone was paying attention. I don't like that. But sometimes I'll make a mistake because I'm trying to see whether you have followed the logic properly. I don't really do it that often because it's not really worthwhile, but sometimes it is. Sometimes it's good to see whether people are awake or not. Stella.
With the negative 2a,
Yes.
why is it a negative? Because isn't it negative times negative?
This one here or this one here?
No,
So that's negative 2x squared, and that comes from minus 2 times by positive x squared.
Oh, okay, yeah.
To give me my minus 2x squared. Does that make sense?
Yeah.
Cool. In a moment, I'm going to go through one more non-monic again, just to give you a bit of a reminder about how to do the non-monic factorizations. So I'm going to pause this video now, and I'll come back in a moment. So what caused a few concerns, in a way, was the ones which had letters in them, like x minus a, x squared minus ax minus a squared. So this is k or something in the textbook. And I thought I might just quickly do it. I'll use the, what should I do? I'll use the box method just so you can sort of see it. But really, it is quite tricky to get your head around it, but in a way, in some ways, it's no more difficult than the other problems. It's just that we don't have a final number, right? It's like another variable A instead of an actual specific number. But our execution is pretty much the same to start with. And that is, I put the binomial along the row here, and I head the columns with the different parts of the trinomial, and then I go for it. So x times x squared is x cubed. X times negative ax, well, x times x is x squared, and then I've got a negative ax times by 1, which is negative a. So it's negative ax squared. X times negative a squared is negative a squared x. So that's okay. I tend to write my variables in alphabetical order, but I'm assuming that x is the main variable here, and that maybe a is just standing in for another unknown number. Minus a times x squared is minus ax squared. Minus a times minus a x is positive a squared x. A times a is a squared, and minus times minus is positive. Okay? Then I've got minus a times minus a squared. Minus times a minus is a positive, so it's a positive a cubed. So that's fine. But it's the next bit which is a bit tricky. Now, I'm assuming that x is my main variable, right? So if I write this out as a whole expression, I'll show you what I mean. I've got my x cubed, then I've got my minus ax squared minus another ax squared. Oh, this isn't a very good one to show. Then I've got my positive a squared x minus another a squared x, and then I've got my plus a cubed. So if I go down here, I end up with x cubed. So that's that one done. And then I've got minus ax squared minus ax squared. So if I've got two terms exactly the same and I've subtracted them twice, that means I've got minus 2 of them. So it's minus 2ax squared. Then I've got a squared x minus a squared x. These are two terms that are exactly the same but opposite in sign, so they cancel out. I've gone plus a squared x, then back a squared x will be back to 0. And then I've got a cubed to finish off with. And so the final one would be plus a cubed. And that's that. Now, I didn't get to show you this, unfortunately, because I didn't pick my problem very well. But for one of the problems, I think, I'm just going to make this up, right? I know it's not exactly as you had. But I was like x cubed plus a squared x minus, I'll make that a minus actually just to make it a bit more tricky to do, minus a squared x plus ax. Now, they're not like terms, and it's kind of legitimate just to leave it like that, to be perfectly honest, if you're not given any more information. But often, what you need to do is you need to write it in terms of x, as if x is the main variable and the other ones are just there for other reasons. So you can do it. So this is just x cubed here. And what we're going to do is with a squared x and ax, can you see how there's a highest common factor of ax? I'm not taking the highest common factor this time. I'm just going to take out the x part. So that leaves me with minus x outside of, no, actually I'll do it. So this is what the problem I've tried to be too tricky and I'm going to make it more confusing, but bear with me. So then I'm going to add a squared, that's the bit left over from the a squared x, sorry, minus a squared, and then I'm going to have my plus a. So I've taken out the minus a squared there, I've taken out the a from there, and I'm going to put my x there. Say that again.
So in front of it, x cubed plus, and then in brackets, negative ax squared. Couldn't it just be x cubed minus ax squared plus a? Not ax squared plus a?
Do you mean this top line here?
No, the bottom one. How come there's a plus between x cubed and then the brackets? Shouldn't be a minus.
Oh, right, because I've taken that minus in here.
Could you leave the minus outside?
Yeah, I could do that as long as I made that a minus there then. Yeah. I know it's a bit confusing because of that. And then just to make it a little bit tidier, I'd go x cubed plus a minus a squared x. And as Charlie was sort of saying, if you made that a minus there, you'd have to make sure that's a minus there, and then it would be a squared minus a, and that would be legitimate as well. It's the same thing. So the point I wanted to make really is that the reason why you might do that is so that you've got an x cubed term and an x term. It just looks a bit tricky. But so you'll sometimes come across that. But that's a pretty line ball decision, that one, a bit of a difficult one to do. So what I thought I'd do is I would just finish on reminding you how to do a non-monic. So we've got 4x squared minus 4x. And I've got a slightly different way again to show you how to do this. You don't have to do it this way if you don't want to. So we've got 4x squared minus 4x minus 15, but they all start in a very similar fashion. That is, we start by multiplying a and c together. So that's 4 times minus 15, which is equal to minus 60, isn't it? And then we put the coefficient of the x term underneath, so that's minus 4. And this is the bit we're interested in to start with, minus 60 and 4. Now the minus here, just to remind you, the minus here means that we are looking for two numbers that are four numbers apart from each other. If this is a plus, then we would be looking for two numbers that add up together to give me 4. But because it's a minus here, we're looking for two numbers that are 4 apart. So two numbers that are 4 apart that multiply together to give me 60, what would they be? Anyone can answer? Harry? Sorry? Yeah, 10 times 6. Oops, I'll go back to the colour. I'm going to space this out a fair bit too, and you'll see why in a second. So 10 multiplied by 6 will give me 60, and they're 4 apart. We need to end up with negative 4. So I'm going to apply the negative to the bigger number, so negative 10, and that'll give me plus 2. Now here's the bit that's probably going to, I think it was Henry that annoyed last. I'm going to annoy you again, Henry. What you do then is you're going to write both of these as fractions with the 4x on top. The 4x just comes from here. Are you annoyed yet, Henry? Now what you're going to do is you're going to cancel down both of those fractions. Okay, so 4 goes into itself twice and goes into 10 5 times. 4 goes into itself twice and goes into 6 3 times. So you can do that off to the side, and then you'll find that this is equal to exactly 2x minus 5. I'm reading my fractions. 2x minus 5, 2x plus 3. And that's the correct factorization. So numerator plus or minus the denominator. So I cancel down the fraction. That left me with 2x and minus 5 on the bottom. So I've got 2x minus 5. I've taken this fraction and I'm left with 2x on the top and positive 3 on the bottom. So 2x plus 3. And this is not a proof of how it works, but if you did expand that, you will get that. You can prove that to yourself right now. You don't have to, I'm saying, but you could do. You can set this will do. But you can sort of start to see that 2x times 2x will give me 4x squared, and minus 5 times 3 does give me minus 15. So it's about convincing you that the middle term's right. It works. I'm not going to go through why it works because it's kind of all about breaking your polynomials apart. Okay, the time is now nearly 2:35. I'm going to stop the video and I'm going to hand out a puzzle sheet.